Excellent. Ahoy! Ahoy! Thank you. There we go. I'm Jason. I'm a full-stack developer at Bump Digital. If you don't believe full-stack developers exist, then I'm not here. Someone in here will get that. That's right. So yeah, I work at Bump Digital on Umbraco things, either on top of or next to or underneath Umbraco, depending on what we're doing. And I'm Umbraco MVP for my third time this year, and a core collaborator, so testing and merging and closing PRs sometimes into core. So if you've contributed to core, maybe I've closed one of your PRs. No, maybe I've merged one of your PRs. Sorry. So why am I talking about async? Because I was grumbling about it on the community Discord months ago now, and things have changed since then, and I'll talk about that in a minute. But there's still some confusion and suspicion in the community around async await. It's been 11 years, but I still get people complaining about it and being like, oh, it's some newfangled, this newfangled programming technique. I'm like, what? But also, it's super important for our performance and sustainability of our Umbraco apps. It is key, and it probably affects us as developers working with Umbraco more than it affects anyone else, perhaps. So yeah, it's been a first-class citizen in C# for over 11 years now. I remember when it was new, and that makes me feel old. It's a core part of modern web development. Whatever stack you're working with, whether it's C# or something else, JavaScript, it doesn't matter. All web is async now because it has to be, and we'll talk a bit about why in a minute. It's especially crucial to performance in ASP.NET because if you're not using async await, you are throwing away performance in .NET. .NET really needs it to be performant. And it's a really nice implementation. Like, we've had async await for 11 years. I don't know if anyone's been working with JavaScript in that time. Can I remember, like, callback hell? And then we had promises. And then finally, async await, like 3 different generations of asynchronous programming. And C# has had that this whole time, and it's been lovely. So it's great to use. But before we get into asynchronous programming, I need to talk to you a little bit about threads, because that's where async and await affects performance in a .NET application. Threads are, there's lag. Okay, there we go. Threads allow a single process to do more than one thing. At a time. So you're working at a computer. Your computer can do more than one thing at once, right? But also you're using applications that can do more than one thing at once. If you think about the old days of computing, where you're at the command line, you start a program, it does one thing, you do another thing. Threads are how a single program can do multiple things physically on a computer. But more specifically in .NET, it's how all our code is scheduled to run. So for code to get to the CPU to do stuff, it's going to run on a thread. That is the context that it runs inside. It's super important for ASP.NET performance. And this is where it's kind of unique, or as web developers, we're kind of unique, because we're not building software like Word or Photoshop, where there's one person sat at a machine doing one thing at a time. We're serving hundreds, thousands, tens of thousands of users, all making requests, all wanting our app to do things. And our app is doing lots more things than it ever used to do. We're calling more APIs than we used to do. A single user is using way more resources than they ever used to. And there are more concurrent operations happening. And in .NET, threads live in a thread pool. Yes, thank you. I have threads in my thread pool. There we go. If you remember nothing else, it'll be there as a thread pool. But just like this very tiny pool, there's a practical limit as to how much can fit in there, right? In our .NET apps, we can only practically have so many threads that our application can use at any given time. So we can only be serving so many, in theory, serving so many users at once. So there's a practical limit because they're expensive. How many threads you can have is a function of how much memory you've got and how many physical CPU threads are available. And you can generate more. You can tune your application if you're up for that, to have exactly the right number of threads for what it's doing and the environment it's running on. But actually, as web devs, sometimes we don't know what environments we're running on. And we don't have the ability to tune in that way that we might like to. With async await, we have a nice, easy way of knowing that whatever we're doing, whatever architecture or server or machine our code is being deployed to, that our code is as efficient as possible when it comes to using threads. So we're not pulling all the threads out of the thread pool. But we'll talk about that a bit more in a second. First, First bit of audience, there'll be a lot of audience participation. This is the first bit. If you could get a smartphone, just scan. It's not like malware. You're okay. It's just going to take you to a web page. And if I could get kind of a show of hands once people have kind of got that and can see a big green button, and yeah, it's working at least, so that's good. And I'm going to do all the things they say not to do. I'm going to switch between a PowerPoint and live coding, and it has failed immediately. There we go. So, whoa, that's the wrong one. There we go. Whoa. People have already hit the button. Come on. It says so. Don't hit the button until it's time. Oh, it's a green button. Damn. Do you know what? It used to be blue. It wouldn't have had that problem if it was blue. Right. So, really simple. I'm going to count down from 3, and I'm going to get you to push that button. Right. So, ready? 3, 2, 1. Smash that button. 26. 53. Whoa. Well done. That's way more than I've had before. I don't think you've DDoSed my machine. Brilliant. Okay. And if any of you manage to push that more than 3 seconds away from each other, I mean, that's impressive. You shouldn't have been able to do that. But just to show you what's going on with this code, so you've just all hit an endpoint called get thread ID. I'm sleeping the thread just to guarantee that you all do hit this at exactly the same time, because with the best will in the world, you can't all push a button at exactly the same time. Computers are faster than us. So I'm slowing it down to give us a chance, and then all I'm doing is I'm pulling the current thread ID out, and I'm returning it. So the number you got, what numbers did you get, by the way? Shout out some numbers. Lots of different numbers. So when thread.sleep hit, that thread was tied up, so the next user coming along had to get another thread out the thread pool to serve it, so that's what .NET did. It pulled a thread out for the request. It was assigned to you, and that is the thread that was used for your request. Simple, right? And that's all it's doing. We'll look at that in a bit more detail later. But yeah, that's basically what happens. A thread's being pulled out the pool, assigned to you for the duration of your request, to go through all the code that you've got to go through. In this case, it's just pulling the thread ID. It might be doing all sorts of other things. We don't know. Well, in this app, anyway. So I'm going to step through some code, because I've got some services I want to talk to you about in my aptly named cheese controller. So I've got 2 controllers in my app. I'm running a cheese shop at the moment in my app. And I have a cheese controller. And I've got a really simple, really simple API that when I click make cheese, it calls my make cheese method on my cheese service. And inside a cheese service, I've got a cheese client that is calling get cheese, right? Think of that like a HTTP client, okay? I can't use a HTTP client for the demo because this isn't on the internet. But yeah, think of it like a HTTP client. It's getting cheese, and it's going off to the internet, and it's waiting a good long while. About 5 seconds to make cheese. Who knew it took 5 seconds to make cheese? It does. It's returning cheese. In this case, what do we got? Compt, a firm French cow's milk cheese. There you go. And return to the API. I didn't actually build this out, so there's nothing to see once it returns, but it goes through. And I have exactly the same controller, but it's all asynchronous this time. So there's an async version, so it's returning a task of cheese. And the only difference here is we've got an awaitable make cheese async method that we're calling. We step through it. Again, we're going to have to wait about 5 seconds, because that's how long it takes to make cheese. So it executes in exactly the same way. It takes exact same amount of time, but one of those methods is drastically more efficient than the other. Let me show you how and why. In our async, I'm used to using a different keyboard, and my shortcuts are all different. There we go. So the difference being, in our make cheese async, we are awaiting this method here. So what gets returned is returned at the point that the await is hit, because the task is returned, instead of the actual, the cheese task is returned. I'll show you. It's easier to show you. So here, I can basically change this up a little. And I could say, whoops. Oh, thank you, Copilot. There we go. Boom. Oh, yeah. There we go. And, oh, no. I did say on my slide I'd make mistakes, and that is the mistake I made. And let's pop a breakpoint on that. And let's just step through this to be really clear, the difference that this method makes. So the same thing happens. Make cheese async is being called. The thread is getting to this bit of code, and it's going to call get cheese async, but it's going to await it. So at this point, and this is where all the magic in async await happens, async is kind of arbitrary, await is where the magic happens. Await says, which is kind of weird, we can wait for get cheese async, but don't wait for it. The language isn't great, right? But this is what's happening. So at this point, we're awaiting it, and the thread has immediately returned to what called this method. So we've gone from here immediately back to what? Here, which is like, that's not normal control flow, right? That's what await is doing. So my thread has gone up to whatever called it, and I can do something else with that thread now. I can carry on. I mean, in this case, I'm just writing to the console. Maybe I've got other APIs to call. Like if you're responding to a user request, you've got multiple APIs to call. You've got other things to do. Because you now have that thread back, you can do stuff with it. I could make 5, 6, 10 cheeses asynchronously in that time, but it only takes 5 seconds because I can do them all at the same time, for example. Now, that's quite unusual. You wouldn't necessarily do that. And I'll show you with the normal flow is what we saw already, actually. So at this point, we're not actually returning the cheese task until we're awaiting it, which I didn't put a breakpoint on, but that's what is happening. And then we can return the cheese. And you'll notice that at no point during that was I actually waiting 5 seconds for cheese to be made. I was sat on breakpoints. If I was doing a thread.sleep, I'd have to wait between breakpoints for those 5 seconds. But because this is asynchronous, and we can wait for the amount of time to pass separately from what our current thread is doing, we've not waited for that cheese to be made. Obviously, it took me way more than 5 seconds to explain all that, but we've not had to wait for that. So let's just undo all of this, all these changes that I've made here, so we make it a normal, just a normal method. There we go. So in my make cheese async service, I awaited. I stopped awaiting here so that I could do other things, but normally I'd await. So what happens? Well, the same thing happens here. If I'm awaiting make cheese async, the thread goes back to whatever called this. So I don't know what calls that. I don't really understand how thread scheduling works in .NET, and I don't have to care. Actually, that's the nice thing about this. But that thread maybe went all the way back to the thread pool for another user in the meantime. So instead of being sat there waiting for 5 seconds for cheese, it can do anything else that this application needs it to do. That is the power of async await, that we're freeing up threads to do other things. Now for the carnage. Oops. Come on. Oh. I'm used to having a real keyboard, and all my shortcuts are different now. A dramatization of what we've just seen. We're going to act this out, just to make it really clear what goes on here, and try and understand it a bit better, because just for fun, really. So here is my cheese service with my cheese client calling get cheese. So Matt, would you like cheese? Would you like some cheese? So imagine Matt is a user of our application, right? And he has requested some cheese. Okay, fine. So I'm going to be a thread in this scenario. So I'm going to get in the pool. I'm in the thread pool, right? I'm waiting around to make someone some cheese, right? So I am going to run this code now. That's what I've been invoked to do. So I need to call get cheese on my cheese client. My cheese client, I'm not going to go through all the code underneath, but that involves making a HTTP request over the internet and getting it back. So I'm getting out the thread pool. I'm making my request. You are going to be the internet. Louis is at the back there. You can wave. Stand up, Louis. Stand up, Louis. Brilliant. I'm the thread. I'm going to send this box to my trusty network adapter over here. You're going to send it over the internet to Louis. And he's going to send back a request, right? Now, this is how the internet works, right? No one is connected directly to an endpoint. We're going out over loads and loads of network nodes, loads of hardware, loads of miles and miles of cable. That is slow. That is so much slower than what your CPU can do. I'm a thread. I should be able to run at the speed of, I'm pretty fast, right? Gigahertz speed. But right now, this isn't async, so I'm waiting. Matt, would you like some cheese? Or you don't like cheese? Sorry, do you like some cheese? Well, here's the thing, right? I was the last thread in the pool. So you've got to wait. You're waiting for me now, because I'm waiting for this. So, yeah, I mean, we're stuck, yeah. Here we go. Brilliant, thank you. Oh, crikey, that's a heavy one. Here you go, Matt. Yeah. That was fun. And I'm done. I've given Matt the cheese. I can hop back in the thread pool. I'm ready for the next user. It's a terrible application that has only one thread left. Don't be in that position. What about if we're doing this asynchronously? Let's do that. So I'll get back in the thread pool. Would you like a cheese? Sure. OK, so I've been invoked. I'm jumping out of the thread pool. I'm going to respond to that request. I'm building my own request to send out to the network endpoint. Here you go, thank you. Over the internet it goes. But at this point, instead of me being stood here waiting for that box to come back, I can get back in the thread pool. Does anyone want? Yeah, another cheese. Oh, the box. I need the box. Sorry. And I can. Gosh, the internet's slow today. Come on. Well, I'm going to hop back over here. I mean, I've only got 2 boxes, but. Yeah, but hey, I'm fine, right? I mean, I'm not waiting for anything. And just to make this clear, so people often think that we're using background threads or something. That you, my network adapter, you're going to tell me when you need me to do something, right? So I can respond to that. I mean, yeah, that's how that works. There's no threads waiting with async await. They're just doing something different in the meantime because we're relying on our. Okay. I could have done with someone else being another thread. This is, yeah, okay. Just give it to someone who hasn't had a cheese. There we go. There we go. Phew. There. And I think we just about delivered twice as much cheese in the same amount of time there. I mean, if it's a heavier bit of cheese, that one too. I said it would be chaos. So, over the internet, what are we waiting for? So all I/O adds latency. Every time something needs to go out of the CPU effectively, but out of that machine, some kind of network call over the internet, maybe you're calling an API, maybe you're reading from a database, maybe you're reading from disk even. Like database is a great example. We think databases are quick. They're really not. Like if your web app is in Azure, the database server is not right next to it, and they're not directly connected to each other. There's networking stuff in between, and there is latency. And it might be very little amount of latency, but it's so much more latency than what your CPU is capable of doing. And we're just asking it to sit there. So yeah, network, HTTP APIs, blob storage, Redis. No, not Redis. Boo, Redis. Is it Garnet now? Someone else told me something else that they're using that isn't Redis, but is Redis. I don't know. Database, disk. Now let's think about Umbraco specifically. In the days of V8, which if they're not over for you, they will be soon. For network calls, V8 was never great, I'll be honest. Because as soon as you need to load balance, as soon as you need to start provisioning for extra users. Well, in fact, let's talk about it. So if I want to get more threads in my thread pool to be able to handle more users, and I'm not using async await, the only thing I can do is add more CPU cores. That's all I can do. And so you're either scaling horizontally or vertically. Now, if you're scaling vertically with a massive CPU, most of the time it's doing nothing, it's costing you a lot of money. If you're scaling horizontally, yeah, great. You can dynamically add the number of workers, endpoints, whatever, that are handling requests. But as soon as you start scaling horizontally in Umbraco, what do? You move all the things that were really fast to places that are really slow. you move your IFR system to blob storage. That's a network call now. That takes an awful lot longer than when it was on disk. You use Redis for your session state. Hey, session state before was free. It was in memory. Like, that was basically instantaneous. Now it's a Redis, HTTP call to Redis away. And you're using all your threads all the time to do that stuff. And if you can't use async await, or you're not using async await, your threads are waiting for that all the time. And so in my experience, I've seen so many, certainly V8 sites that are running on hardware that's 2-3 times more powerful than really it needs to be. It's a lot better now. And when I first gave this talk, I was complaining about all of Umbraco's core services not being async. A lot more of them are now, if you've seen the stuff with the management API. So that change is happening, and it's getting a lot better. But it's been tricky for a long time. Disk's a weird one. We'll talk about that again in a minute. But think about how much stuff we read and write from disk as well. Like, disk is slow, mostly. So, oh yeah. And that's the, this is where this is the worst kind of performance bottleneck, is thread starvation. If you've ever come across it, it's a pain, because it doesn't look like your normal bottleneck. Because it's not using a lot of CPU, it's not using a lot of memory, it's just that your computer's physically waiting for stuff. And so you're like, well, why is this slow? And you debug it, and it becomes obvious once you've seen it a few times. But yeah, when there aren't enough threads left in the pool to serve your users, that's thread starvation, and you get, yeah. But async await unlocks that, because as you saw, we're sending the threads back all the time. So, just double check this. Oh, and I nominally put sustainability on the title for this, because it is, because anything that's to do with efficiency when it comes to computing is essentially sustainability. The nice thing about it, or the really obvious thing about it, is we're not talking about like some, you don't need to be some eco-warrior to appreciate that. It's just efficient. Like, whether you're looking at the bottom line hosting costs, whether you're trying to save the planet, this is a good thing to do. It's better for everyone. Now, we're going to refactor the app live on stage. Why not? So let's take our thread ID controller, and I'm going to make this asynchronous. So instead of thread.sleep, so this is kind of, we'll use task.delay, which is I guess the asynchronous equivalent, right? So instead of tying up a thread, pardon me, for 3 seconds, we're going to await for 3 seconds. And this is going to get cross with me. I'm just going to, let IntelliSense do it, but I don't want to call it that because it will ruin the endpoint. And I need to stop and start my application when doing that. I mean, you're always going to stop and start your application when refactoring this kind of thing. But because we've changed the type, the return type, from an integer to a task event. And task, like, people complain because it's a refactor all the way through the stack. Yeah, it is, because it's a completely different programming paradigm, right? We're doing something, the code works fundamentally very differently. It doesn't look like it, because we've just thrown some async await stuff in there, but underneath, behind the, under the hood, .NET is doing some incredible thread gymnastics to make all of this work. Right, hopefully, if you could all go back to where we were before, I'm going to hit reset on this. Oh, how many were we using before? Was it 50-something, 53, 54? Yeah. Well. Oh, the QR code, yes, I can. It's this one here. Ah, there we go. So if I could get a kind of a show of hands again, ideally, to make it a fair test, there's roughly the same amount of people do need to push it. Should have made that clear earlier. So, oh, sorry, I'll leave that up a bit more. So we've got a few. Is everyone happy that we can get cracking? Okay. So I'll hit reset. So let's count down from 3 again. 3, 2, 1. Hit that endpoint. Push the button, whatever it is. Yeah? Is everyone? There you go. So this is the total number of threads that have been used to handle those requests. So where we had 50-something before, we've now got 9. That's, if you were having to scale CPUs just because you've not got enough threads, how many less CPUs is that, right? How many fewer instances required? 5, thank you. I can't do the maths in my head. Thanks, Ronald. Yeah, that's 5 fewer CPUs required to do exactly the same amount of work. Like, and how much of a, no, yeah, I appreciate that our code is more complex than this in most situations, but when it's not, when it's like this, that's free performance for very little work. I won't explain task. I've not got time. No, so task, so the difference with task, why it's there, why you have to refactor it into a different object, because you are changing the return type, right? It's a task. Task is just a really lightweight state container that keeps track of the task, what you've asked it to do, right? So you wrap your method inside a task so that other threads can keep track of when something is done. That's all. It uses a tiny amount of memory, and it's a really simple refactor, which I think we can all do, right? So we've done that. Oh, yeah. So, I'm just changing the brightness on it. It's not launching. There is an exception. So this is where, I said async await is doing a lot of gymnastics under the hood and doing some really clever stuff. That, of course, is not free. So it does take time for that to happen and for .NET to shuffle threads around, to move contexts with those threads where it's required. My example of that is my really simple read file controller. In fact, let me show you my read file controller. Yeah, text file. So yeah, this is dead simple. I've got a stopwatch, and I'm measuring how long it takes to read text.txt. And there's nothing in it, so this is pure latency we're measuring here. And it's how long it takes. This is how long it takes to read that file, right? Except it's not, because we're awaiting it. Let me refactor this so that it's not async. And I don't actually need to change the return type here. Oh, no, I will, because it makes it even. Whoops. Oh, damn. It makes it even more way. So what were we, 30,000 something before? 30,000. So this is ticks as well. So the performance change here is too small for you to really see in milliseconds. This is the kind of speed we're talking about. So a tick is 100 nanoseconds. You can see the average here is an awful lot lower. And that is the overhead from async await. And the reason why that is so much more performant, and actually in live hosting, this may not be true. This is one of those things where you need to know your hardware. I'm sorry, I know web devs don't like that, but you need to know your hardware to know whether async await is going to be more performant. In my case, I've got a super fast SSD in here. There is very little latency. We can read that text file really fast. .NET, just doing async await around that is, 10 times slower, or a bit, 8 times slower or so. So it's something to bear in mind. It's a magic bullet for when it's I/O out of your machine, but if you're talking to disk, it's not. But it depends on your hosting. I'm told that Azure is not particularly speedy, for example, on its local disk, even on the SSD ones, so maybe async await is more efficient. But actually, for most of us, we're not reading loads of text files unless you're using usync at startup and reading loads of text files all at once. So that's where it might matter. But that's the exception that proves the rule. Every time. I'll get these keyboard shortcuts down eventually. I should have brought my actual keyboard with me, then we'd be fine. So async most of the things. And I say async because really it's all about await. It's all about awaiting. That's the key thing. That's where the magic happens. Await most of the blocking I/O apart from your really slow disk. Really fast disk, sorry. And stuff in Razor. I'm not sure why Razor deadlocks itself. If you're using Razor for your HTML, it deadlocks itself. So, it does. So if you can, always use the partial async and render partial async and all of your async methods inside of Razor, because if you don't, it might just use more threads than it should do. I think that's everything. So if you want to go for a real deep dive on this stuff, there's an amazing video from Scott Hanselman and Stephen Tobe talking about building async await from scratch. So that's the first QR code, which is really cool. It's an hour long, and I really nerded out over that. Or There Is No Thread, which is a really old article. It's an article from Stephen Cleary in 2013, because people didn't believe that there weren't magical ghostly background threads doing all this stuff underneath the covers. And it's a real kind of low-level explanation as to how await frees up those threads and what's going on when you're waiting for stuff over the network. And it's where I stole all my ideas for this talk from. But that's it. That's been me. That's been async all the things. And please do async await all the things. Thank you.